Okay, so how do we get our GoPiGo to dance? You're going to add your dance method into the child class that I've provided you. But for this demonstration, I'm going to add a dance method into the parent class. So right now, all it does when the parent object, the Pigo, when Pigo dances, he just says the parent dance is lame. Because the child class, that's where the dance method is supposed to exist. But I'll make one for the parent class anyway. Um, let's say I want to make the robot look left and then slowly look over to the right. So kind of like scan its head. What I can do is I'll start a range. Now I know up here the midpoint for my robot is 77. So I kind of want to look maybe 20 degrees to the left of that and then look all the way over 20 degrees to the right. So kind of scanning back and forth a little bit. So I could do for X and range. So the starting point would be self dot midpoint minus 20 and then go all the way over to self dot midpoint plus 20 and oops, sorry, 20, and I'll go up by 5 each time because otherwise it would take too long and it kind of is too hard to tell. Um, so I will then tell my servo to go to that position in X. And then the thing is, though, I also have to give the robot just a fraction of a second to give it actually time to move. Otherwise, if I go on to the next thing, the computer will just spam all these commands to the servo, and it won't have time to do any. And all it'll have time to do is the very last one. And so you do need time.sleep, and then let's say a tenth of a second. That's all it really needs to turn its head. But you have to give some sort of time to do that. Um, okay, and this makes the computer sleep, so the app is paused, but the motor controller, the GoPiGo, can execute its command. So while the processor of our Raspberry Pi is sleeping, the GoPiGo can still be moving. So, okay. So right now I have it moving, moving its head from one side to the other, and um, maybe then I can back up. So right now I don't have I have provided you some encode methods with encode forward, encode to the right, encode to the left. Um, So I'm going to make one more encode uh, backwards, and that's self, and it'll take the encode as well. And so I'll do the same thing. I'll announce that I'm into the console window, into your SSH window that you use to remote control it. I will announce that I'm moving so many rotations. Since it's 18 rotations, I'll take whatever number you give me to turn, and I'll divide that by 18 so I can say, hey, I'm going to turn my wheel, so many rotations backward. Okay. And then I'll set the encoder target. This is something built into the GoPiGo. And so I will both wheels get it, and with the encoding value that's passed to me. And then I will do backwards, BWD, and now I do a time.sleep again, similar to what I did, and I noticed it takes about, for every one rotation, it takes about almost just shy of 2 seconds to do one rotation. So that's why I wait this long. Sometimes uh, maybe this is too long, maybe it's not long enough. It's that can be an issue. And if the encoding fails, then it'll just keep rotating or keep going backwards for as long as the sleep is waiting. So if the encoding fails, um, it'll just it'll overturn or over travel. Um, Something I'm still trying to work out myself. But anyway, so wait 1.8 seconds for every rotation. Um, is what this is. So now I have an encode backwards. Um, I need to add in comments on top of that too, but there we go. So now uh, after we have looked left and right, then let's go backwards, encode backwards by let's say just a little bit, and then we'll do self encode right just a little bit, and then self dot. We'll try all the moves just by 5. Um, all right. So I look left and look right. I go backwards. I spin around to the right a little bit. I spin around to the left a little bit, and then I go forward. Um, and then I can maybe let's see. I could try doing the same sort of thing, but I'll go up by 10 to make it go even faster. All right, so slow look, back, right, left, forward, and then quick look. Okay, I mean, that's a start. And so now I'm going to push this code out to my robot, give it a try to see how it looks, and go from there. And then I'll iterate and improve upon this.